Hi folks, Dr. Biittner here with a video that I'm hoping will explain to you what our expectations are and what you need to do for the lab 4 or mapping assignment. And just a reminder that this is the third lab exercise that's been posted. So make sure you're keeping track because there's only 3 more labs remaining after this. There's one on dating techniques, one on subsistence, and one on bioarchaeology. So if you haven't completed any of the lab exercises left, you have to complete this one and all of the ones that remain. Now, I've been asked if I can post the remaining labs in advance. And as you've seen, this term has been a challenge for all of us, myself included. So I can't promise that I can get the lab materials up any sooner than I have been, other than I am going to get back on schedule so that I'm not posting things late. If there looks like there's a possibility that I can get them done, run them past Dr. Prince for his feedback and input and insights and input, and then get them up for you, I'll do my best. But again, no guarantees. So we'll just see what happens. Keep in mind that the difficulty level or the perceived difficulty level of the lab exercises depends on a number of different factors. And for some of you, this mapping exercise might be really easy because you've already dealt with maps before in one capacity or another. But for those of you who've never looked at a map before, the information can be a little overwhelming. So again, that's why I'm making this video for you. So let's get underway. So as you've seen in all of the lab exercises, I've provided you with some background information. So that's what the first few pages are, is just general information that you need to know, in this case, about topographic maps and contour lines. But in terms of the lab activity, you're not really dealing with topographic maps per se. Instead, what you're working with is data points and using it to construct contour lines. Okay, so you get an idea of what the topography of the region is like. And then for the second half, what you're doing is learning how to read provenience from an existing map and then take that provenience and plot it onto a map of a different scale. So I'll walk you through each of these exercises. So just read through the background information. And of course, if you have any questions, please do bring them up with me, either in Collaborate session, or you can always raise them during office hours. And don't forget that in addition to my office hours, Dr. Prince holds office hours as well. And he's a great resource for these materials throughout the term, including lecture content, but especially for those of you registered in his lab sections, because he's the one who marks your lab activities if you're assigned to his lab section. Okay, so let's scroll down here to our lab activity. And you'll just see that the kind of key things that you need to focus on are starting on page 2, where I talk about what are contour lines, right? And again, so contour lines, just to summarize this, are a method by which we take the 3-dimensional profile relief, or basically all the landform features, all of its waviness, bumpiness, all the differences in elevations, and translate that onto a 2-dimensional piece of paper, right? So that's the key here, is that we're trying to represent 3-dimensional space on a 2-dimensional sheet of paper. And so what we do is we mark what the elevations are at specific points. And in this activity, there's a grid system where they've taken elevations at certain meter intervals, right, in terms of horizontal and vertical provenience. And then what the contour or the elevation point is getting you is basically its relative height to the datum, right? And then what we're going to do is we're going to kind of connect the dots, as it were, connect the points, as it were, to figure out where the various highs and lows are on the survey area. So we're capturing basically the relief of the landscape. And then I give you some helpful tips just about them, about how contour lines don't cross over each other. They close in and of themselves. And so all numbers within a contour line are all going to be either really high or really low. And then so all the ones on the outside should be then low if the ones on the inside are high, and vice versa. Okay, and we'll see this as we work through it. The spacing tells us something about the intensity of the slope. The more closely they're spaced, the more steep the slope is, the further apart they are. That means that there's very little elevation differences, so we have a pretty level surface. Okay. And so then I've given you some images that show you how they should work on a map, and then we get into the mapping the survey information itself. And again, there's two different kinds of information that we're actually looking at on these maps. So the first one we're going to look at, again, is the elevations, and we're going to draw some contour lines onto it. And then in the second map, we're looking at how we can take surface find quantities, or the number of artifacts and ecofacts that have been found on the surface during the survey, and how we can use contour lines or draw lines that basically in the same principle, but instead what we're looking at are frequency lines that will tell us something about the distribution of artifacts and ecofacts, or of material culture more broadly, across that surface, across that landscape, right? And then we can start to think about the relationship between the relief or the surface, right, all the different landforms on the surface, and the artifacts that are associated with those, right? So if we have a low area, for example, maybe artifacts through natural processes like erosion or water movement are being moved down into the low area, right? And they're coming down off of a high area. So these are the types of things we can interpret. Plus we can kind of figure out then maybe where people's activities were being focused on the basis of that. So that's what we're going to do. Okay. So let's look at what we're doing for the first exercise. So again, we're going on the principle that contour lines are joining points of equal value. So on our first map, again, we're looking at elevation. In the second map, we're looking at numbers of material culture of artifacts, right? And so our fictional scenario is actually based on a scenario that's provided to you in the textbook, but I've modified it here for this exercise. And the idea is that archaeologists have completed a survey of a large section of land adjacent to the Sturgeon Lake. And they did this systematic field survey doing 10-meter intervals. And so basically what they were doing is, as they were walking along, they set up a grid, which I describe above how to do. So, and then we talked about this in the video, lecture video, when it came to excavation and setting up the grid. And what they did was that every 10-meter interval, either in a northern or east direction, they would stop, they would collect artifacts that were made there, and then also record the elevation that was present, okay? And so all of these numbers have been reported on figures A and B. So on A, again, these are elevations in meters above sea level as measured by the survey team. We're told that the values range from 111 meters to 140 meters. And our goal is to draw the contour lines on the figure to determine the high and low areas in the surveyed region. So it says, as an example, contour line at 140 has already been drawn on the map, and our job is to add the remaining contour lines in decreasing order. But we don't have to do it for every single meter. Instead, what we've been asked to do is use an interval of 5 meters. So that means we're going to enclose all the areas that have an elevation of 135 meters, then 130 meters, and 125, so on and so forth. But really what they're talking about is between. And I'll show this, I'll do the first one for you as an example. Okay, so this is the map we're talking about. And to complete this exercise, there's a couple of different ways you can do it, and really it's up to you. So you could print out these sheets and then draw on it, scan it in, upload it. You could take a photo of it, upload it. If you have a tablet or a device you can draw on, like I'm going to attempt to do, you can just draw on it. Whatever makes sense, whatever is the easiest format. Okay, so in this case, how you draw on it, how you then get that figure to us is up to whatever is at your disposal. And keep in mind that I mentioned that these figures are also from your text, so if it's easier to pull it from your textbook, whatever makes sense. Okay, so let's see if we can make this work here. Okay, oh, I've lost my menu. Okay, so I'm back. You can't see me, but what you can see now is, again, the figure. And what I'm going to show you is how to draw the first contour interval. So remember that we're working in 5-meter increments. So the first one you can see here has already captured all of the values that are 140 meters above sea level or higher. So you can see that one of the values that's included there is 141. Because we're using 5-meter intervals, what that means is we now need to draw a line, and in between the existing line and the line we're going to draw is going to be all of the values that are 135 meters above sea level or higher, right? Because we're capturing everything between 135 and 140. So to do that, I'm going to find my first 130 on the map, and I see that there are 135 on the map, and I see that there's one here. Okay, and remember that my line is going to go in between then 135 and all of the numbers that are lower than it, right? So we're going to start here and, oh, sorry, and I'm going to draw, oops, why is this not working? I'm going to draw, yeah, let's use that color, a line, and I'm going to go in along, and so 131, of course, is lower than 135, so I'm going to put it outside of the line. And I'm going to put 135 inside. I'm going to keep going, and I'm going to put 135 inside, because remember, I want everything inside this line, or between this line I'm drawing and the 140 line should be 135 meters or higher. So this 131, so I got to go around it. Then I'm going to go down this way around 135. Now I got to go down this way a little bit more. So you'll see that on the left-hand side of the line I'm currently drawing, all the numbers are lower than 135. Make sure all the ones that are higher inside, so I got to go this way. Okay, I'm going to stop drawing for a second, get my bearings. Okay, I need to keep going because there's a 135. Oops. Over here. Sorry, I'm fighting with my pen here. Oh, it didn't work. Okay, let's try this again. Okay, 135, keep going. There's a 136, so I got to get that inside. 135. Keep going. Oh, there's 135 here, so I got to go around there. Keep going. Keep going. Okay, now I've got to zoom down. Oops. Sorry, this is... I don't want to zoom anymore. Oh, why is it... Okay. So clearly I was having some technical issues, but because I refused to edit my videos, we're just going to draw this again, and hopefully this will work and it won't allow me to, or it won't zoom in and out again. Okay, so let's try this again. So remember that we are going to draw a contour line that is going to have all of the values between 135 meters above sea level and 140 inside of it, right? So we're going to capture them kind of in our line. So I'm going to go a little bit faster this time. Oh, a little bit faster because I already got most of this done. Okay, I'm going to keep going, remember, and I'm going to complete this round. Oh, I got to make a big loop here because I got to keep 130 out, but I want to get that 139 in, and I'm going to close it off. Okay, so the line I just drew here then it represents the 135 meter above sea level contour line. So you'll notice that all of the numbers now that are inside this new line I drew, which is red, and I apologize for those of you who are colorblind, you'll see are 135 or greater, right? All of the numbers that are inside the pre-drawn line are 140 and greater. And so you're going to keep doing this at 5 meter interval. So our next line is going to capture everything between 130 and 135, right? So we can see that here, and I'm going to go around here, and I'm going to, oops, I don't know why this isn't letting me draw again. Let's use the same color, and again, I'm going to start to draw my line, and I'm going to put all the numbers that are 130 or greater inside of it. Okay. And so I'm going to keep going until I finish off by completing my 150 meters above sea level contour line. So you'll have several lines on your paper. I believe there's 6 in total that you're going to have. Okay, so that's part 1 and the first figure. Then in the next figure, we're being asked to now do the same thing, draw contour lines on the same figure, but instead of it providing the numbers that are provided representing elevation above sea level, instead they represent the number of artifacts that were found per grid unit on the surface. And so we're going to do the same thing, but now we're going to enclose areas that have more than 10 artifacts, 20, 30, 40, 50, and 60. Okay, so we go to this one and it's the same thing. So again, the trick with this one is that there's no existing line, right? So instead what we have to do is go and find our lowest value area and kind of section that off. And you'll see that along the right-hand side here, there's a whole bunch of zeros. So that's a good place to start, is that our first line is going to start somewhere. And if I look up over here where I have my mouse, my first line is going to start up over here, right? Because the first thing I want to do is section off all the zeros, right? So I'm going to go in between the zeros and the ones here and follow it. And everything that is greater than 0 is going to go on one side of the line. And then I can do that for each 10 increment, right? So the next thing I would then look for would be somewhere with a 10, right? So there's a 10, and so then I can start to circle those in. Alternatively, you can start with the highest number, circle that in first, like we had on our contour map, our other contour map, and then decrease it from there. Okay, so that's the first part of the activity, is drawing these contour lines on these two maps. And I hope that my demonstration, although a little choppy because of the technology issues, will make this clear. The second part involves reading provenience off of existing maps, okay? And so in here, I go through the background of how we set up excavation grids and excavation units, what a datum is, and all these various points, right? So make sure you read through this. And then after you read through this, you'll want to start to take a look at the activities. And for this activities, we have two figures. For the first figure, what we're going to do is we're going to read the provenience off of the artifacts, which are represented by these different numbers, or ecofacts, right? And then we're going to plot it in this table here. Okay. So reading provenience from plan maps requires understanding some basic ideas. So the first thing we need to look at is the scale itself. So in this case, I think, yeah, I didn't state what this is, but this is actually a 2 meter by 2 meter excavation grid. And the reason why we know that is because of our scale bar here. And what our scale bar is showing us is that from the 0 here to the 1, so this entire length, this entire bar represents 1 meter. And if you were to measure this, you can use a ruler or you can use just a piece of paper. But what you'll see is that corresponds to approximately 2 of the squares here. So this bar here would fit into 2 of the squares in this direction and 2 of the squares in this direction. So this whole plan map represents 2 meters by 2 meters. Okay, so 2 meters north by 2 meters east. So now what we want to do is figure out, using this scale, what the location of these artifacts is. And I've given you the first one here for an example. So artifact number 1 is represented by a J, so that's a bone fish hook. So it's the first thing I'm going to write down in my little table here, is it's a bone fish hook. Then I need to record its northing. And our northing, as is explained in the background information here, is how many centimeters north of the grid line our artifact is located. And so in this case, we'll notice that it's not quite the full 2 blocks or 2 squares north, right? It's a little bit south of that. And again, you can use a ruler to measure this out, so you can figure out how many millimeters this bar is. And then you can use that to translate here, or you can do kind of a bit of a guesstimate. And what we see is that this is about, represented by this dotted line Y, that our northing for this artifact here is about 80 centimeters. Okay, so we're going to put that in the table here. Then we're going to record the easting. So this is how far east of the datum line our artifact is located. And so what we see here is that it's not quite halfway. And we know that if 2 of these squares represents 1 meter, then half represents 50 centimeters, then half of half is 25 centimeters, right? Olivia would be able to figure this out. And so we see that it's a little under half. And again, if we wanted to use a little ruler and measure it out, or if we wanted to draw a little sticky note with the little marks representing where these little 25 centimeter divisions are on our scale bar, we would see that it's about 20 centimeters east. So I will write that here in my table. Now we're going to do it for the next one. So artifact 2 is another J, so another bone fishhook. So I'll type that into my table, bone fishhook. Then for my northering, I'm going to do the same thing. I'm going to figure out how far north it is. Well, it's at least 50 centimeters, right? Because it's higher than this line here, this grid line here. It's at least 100 centimeters because it's past the second one, right? We know that the first number one is 80, so we know it's at least higher than 80. If we go up to the next line, that's 150 centimeters, but it's south of that, right? So it's somewhere in between 100 centimeters and 150 centimeters north. Well, again, how far is that? Well, we can divide this up into equal units, or we can guesstimate it a little bit. So I'd say it's about 3/4 of the way up. So it's somewhere probably about 140 centimeters north, okay? Or 145 maybe. Okay, so that's what I would write down then in table 1 for my northing. Now I have to do easting. So how far east is it? Well, the bone fish hook, and remember I'm going from the hook itself, not its artifact number, isn't quite 50 centimeters east, right? Again, it's in about that 40 or 45 range. So I would write that down. Okay, and then I'll keep going through for all of the remaining artifacts. So number 3 over here is a post hole. We have a stone tool or scrapers, number 4. So I'm going to go through and use the information in the legend to identify what material culture is represented on the map, put that in the table. Then I'm going to find the northing and the easting for each of these artifacts. If you forget what direction is north, remember that typically speaking in archaeological maps, north is always towards the top of the page. And we have a north arrow here that also shows us that that's the direction that north is running from. And that's the thing I always tell students I love about maps, is that maps have all of the information on them that you need in order to understand and interpret your map. Okay, so that's the first part of exercise 2. The second part of exercise 2 is where they're going to take these coordinates from here, relating to unit F3, and we're going to map them on this image here. So our first step is we need to find unit F3. And so for that, we're going to look at this grid system. We're going to see that the numbers go are counted starting at 1 in the lower hand corner here and going up to 6. Right, so we want 3, and then we want to go over in an eastern direction until we get F, okay? So the 2 meter by 2 meter unit that we just looked at is represented by this square right here, okay? So then what we're going to do is plot all of those artifacts on here. And so how do we do that? Well, we realize that this line here on unit F, right, is basically representing that 2 meters, and that this line here is representing 2 meters. And so we're going to, for our first artifact, for artifact 1, we're just going to approximate where 80 centimeters would be on this, right? So just under halfway north. And then we said it was 20 centimeters east, so just over 20 centimeters east. And then we're going to draw a little J, right, for our fish hook. Or we're going to put a number 1 there, right? Either or I'll accept on this assignment. And then we're going to go through and piece plot, and you're going to notice that they're going to get all bunched together. So you're just going to have to be really careful. And basically what I should see is I should see this map, all of these little points, these data points from this map here, from our plan map of the unit, plotted now onto our site map in this little square. Okay? So again, we'll have a chance to talk about this in our Collaborate session this week. Don't hesitate to ask any questions, but hopefully this video, even with some of the technical issues, the pausing, going back and forth, that it's illustrated what steps you need to take in order to complete this exercise. And I'll just note that once you've done the 2 contour maps, you have your contour map, your artifact map, then you have your provenience table, and then transposing unit F3 onto the other one, we have some discussion questions for you here. Because as always, we don't want you just doing the activity, but we want you thinking about, well, what does this mean in terms of archaeological interpretation, right? And then the formatting for your assignment, what it should look like in its submitted form is written here. So again, remember that these exercises are 5% of your grade. They're meant to be low stakes. If they're a little challenging, that's okay. Get them done, hand them in anyways, and then take advantage of getting the feedback from them, because again, all of the material from all of the lab assignments can also appear on the midterm and final exam. So it's worth your time trying or at least attempting all of these exercises. So take care, everyone, and we'll see you in Collaborate.